we'll see if I can get that working. If not, oh well. Oh, yep. Now it looks like it's good. All right. So what are we working on? Decompiling Castlevania Symphony of the Night, of course. I'm guessing I need to restart all the captures on all the things because why wouldn't I? That seems to be the way life goes. Or I should restart my computer and make sure that all the things that are supposed to be running are actually running. Oh, that's not what I wanted at all. So we're going to do something around tooling first. I like working on tooling. It's not exciting. I don't think most people think that it's the most exciting thing ever, but it's what allows everybody to get things done. And without good tooling, projects are painful and just not fun to work on. And one of the things that's great about this project is there has been a ton of effort around really good tooling, and that has continued for the year that I've been working on it. Give me 1 second. I want to send one message off real quick, and then we'll get going. Some unrelated stuff. All right. Okay, so what about tooling? What's interesting? So often on the stream, you'll see me run make, and we use make to build all the things. We have some nice output that tells us if our build is successful or not. And that's nice to have. Up until about 30 minutes ago, if I would do something like change a, let's actually, should I revert my change? I'm going to stash my change. And I'll show you what it looks like before and what it looks like after. So if I would, say, touch a header file that we have, I used Skelerang when I was testing it earlier. Merman is probably a good one. And if you're not familiar with touch just updates the time the file was last modified without actually doing anything with it. But we could do something with it. We could, let's actually introduce an error that would cause this to fail. We're just going to put some random text in there. I'll put some numbers in there too, why not? Maybe we'll put the numbers first, so compiler comes in, tries to parse those as numbers, and then fails. And then we're going to make, this actually, let me undo that first. Get a clean build. The reason it's rebuilding is because I changed how the Ninja file is generated. So I'm going to get a clean build. Then we'll introduce an intentional error. And then I'll show you what we're going to do about it. So we'll build. And we kind of have to do this in a couple phases to make sure that our test is correct. So we're going to introduce that intentional error again, build again, and everything's fine. But I introduced an error. So why is it fine? And it's fine because, which file is this? Merman. Because everything that depends on Merman it has been compiled. And the build tools don't know that NO3 and NP3 are depending on this file. We don't have that dependency management. And so we don't get those files rebuilt. Now, if I touch one of those files, again, touch is just updating the build time. The build system knows that that file changed, or it thinks it changed because the time on that file has been updated. And if I make again, now NO3 will fail, and it'll fail because I introduced an intentional error. If I undo that error and build again, what's going to happen? It's still going to fail because once again, the build tooling doesn't know that this Merman file depends on that header file. So I have to touch it again and build it. And that's a pain, right? That sucks. And you can get latent errors that you introduce in a header file, and then later on you try to you think you've fixed those files, but really you've never actually recompiled those. So that sucks, right? So what can we do about it? Hey, Desik, good to have you back. I'm gonna undo my change. I'm gonna stash pop, and I'm gonna build again with no error. And this is just because when the makefile generator changes, it regenerates the build scripts and then rebuilds everything like it should. So what if we introduce some type of dependency management so that we can get that? And that's kind of a hard problem, right? You have all these C files, they have includes. Those includes have includes. Those includes have includes. Maybe there's circular references with include guards. Pragma once, like we talked about yesterday. All these other things. That is a pain, but there's actually usually if you have a problem in the computing world, somebody has thought about that problem, somebody has solved that problem, and so we just need to rely on tooling that's already there. So we're going to introduce our bug again. Now when I make, it found not just the NO3 one that I was touching before, but it found that MP3 is depending on that file as well, rebuilt it, and we get the error right away. And we can undo that error and build again. It'll only rebuild the things that depend on that. It doesn't rebuild everything. Only 7 files had to be checked. Why 7 files? There's reasons for why the 7 files that I can get into a little bit. That's some dependency cleanup that we can probably do now that this is fixed. But how does this happen? And the way is by fixing build tooling. So a lot of the GNU tools have options to emit dependencies. So if we go look at the Merman files, they're now generating, let's see, where are we? Source, STNO3, eMerman. They're generating a, don't prove me wrong, they should be generating a D file, a .d file. Let's find those. I think it was eMerman. Oh, of course. Of course, it's not going to work, because why would it work? Why would anything ever work the first time? Oh, they're not there. Why aren't they there? Nothing ever goes the way that I want. Well, they should be generating .d files, and those .d files have all of the dependency information, all the includes, and because they're generated by CPP, CPP knows all the things that were included and can put them in a nice file. I almost wonder if is Ninja consuming those? That seems wrong. Let's update the Ninja file again and look at deps and comment some things out and see if we can get back to those files. And those are the only rules I changed. So this is going to rebuild. No, it's not. Let's make clean and make, and we'll get those files yet. This won't be the hot mess that yesterday was, where we eventually got to the end. We should get to the end here pretty quickly. I do want to do 2 additional tests and try to finish this off, and then I'll probably push this to PR. And then I think what we'll do after I've proven this out is go look at some of the issues that are currently open in the Soten decomp repository and see if we can solve any of those. If we were going to solve them, how do we approach it, and maybe find something there, which is kind of a good thing for people who might just be starting out, how they would. There we go. There they are. So let's look at the source stno3 merman. There's our .d file. And I don't want the exclamation point there. I don't want the exclamation point there. There we go. And what does that look like? It tells us that for emerman.o, .o is an object file. So there's two ways GCC lets you compile files. One, you can compile directly to a library or executable, or if you want to be able to do incremental compilations, every C file, you generate an object file or a .o file. And that's what most sane build systems will do, so that you don't have to rebuild the world every time you want to rebuild your final output. They're kind of like .class files if you're familiar with Java. Different systems have different similar concepts. So we want to take something like that. We have that .o file, and then this tells us in our compilation path what are all of the files necessary to build that emerman.o. And this specifically excludes any system libraries because we actually don't use any system libraries for building this. So this is every single header, and we'll see emerman.h in there. There it is. And so when I pass this to Ninja, tell it that this dependency file exists, it will then use this to calculate the dependencies. And so we get really nice things like if we change libc, we're only going to rebuild the things that depend on libc. Not quite. There's a little bit of a caveat to that, and we'll talk about that in a second. So that's how that works, and it's really cool. And Zyynamo actually was trying to do this to start with, but he was getting some build failures. I haven't seen any build failures yet. So I'm not sure what ultimately the issue was there. So we do need to do a few things. Unfortunately, we use a tool called MWCC gap for PSP. MWCC gap is used to build or to call MetroWorks, which is a DOS application from Linux. It uses a tool called Weibo, which is a very minimal set of functionality to be able to run DOS binaries on Linux, basically intercept the appropriate system calls and stub out the minimal set of things necessary. As far as I know, it doesn't do any emulation or anything like that. All of the instructions are still run on hardware. So we use that tool, MWCC gap, to be able to run the MetroWorks C compiler. But when I checked this last time, it looks like it may only support certain arguments. Let's look at C flags and see if we can modify that to be whatever we want. So we want to look at .py. .py calls process C file. Process C file has a bunch of, we're still going. Process C file has a bunch of arguments. Do we have just C flags? We do have C flags. Okay, so that's good. Everything that's not known turns into a C flag. So I think we should just be able to pass basically the same arguments there. So we're going to do the same thing. We're going to pass MMD. MMD means create a grab all the dependencies, excluding the system dependencies. MF is where we want them to go, and we want them to go into a file called out.d. We're not going to introduce the dependencies yet, but then we will try building that and see if we get the, I don't know if this is going to work. I've not tried this with MetroWorks yet, but we're going to see if we get the dependencies. And we don't. unknown option MF. This is kind of my experience with the MetroWorks compiler. They say that there are options, and then they don't work for me. So we're going to look at the help. Oops, let's put that in less. So they specifically call out the MD. Oh, but there is no MF. Oh, so it's right. There was no MF file. All right. So where do we find the MF file, or how do we know what file this is going to be written to? If set write dependency file with name and location based on the output file, always based on the file name and source file, and write to the current directory. All right, let's try the GCC deps option instead of MF. It doesn't look like it takes an argument as far as I could tell. We actually... it doesn't... I don't think it matters where this goes. Oops, too much. Let's, what am I doing? Let's put this towards the end. So we're not line wrapping, and let's try it again. We want version PSP-EU. Oops. All right, so we're building. I have verbose builds on, which is why normally you don't see any of this anymore. And let's see if we have .d files in. We don't. Let's see if we have .d files somewhere else that I don't want them to be like source. No, we don't have them there either. What did it produce? So we'll look at build PSP-EU, source, ST. What's one we know? We just worked on. Oh, this won't be anything we worked on recently because we have been working on PSP. So there are no dependencies there. Where are the dependencies? Did I say deps? No, I said dep. It's fine. Oh, MetroWorks. Oh, did it put these? Let's do a git status and pray that it didn't pollute everything. It didn't. Where did it put these files? Well, I'll have to look at that, but it looks like MetroWorks does give us the ability to basically generate the same dependency files, and so we can add that to the PSP build as well. Yeah, unfortunately they don't have the same MF option, and this doesn't look like it takes an argument. So unfortunately, I don't know where it's putting these, if it is putting them. Or let's actually look at the let's look at what it emitted. Are these making their way? Yeah, they are. They're getting there. So I'll have to look into this a little more. And see why these aren't being generated the way that I would like them to be, or where they're going. There's a couple things that I might try to do to debug, but really it looks like I would expect them to be here, and so I'll have to go find some MetroWorks documentation and see what I can find. That's a bummer. All right, one more thing. Yeah, nothing really in there either. All right, so if you're familiar with MetroWorks, feel free to chime in and let me know where MetroWorks puts file. Oh, this built fine. Nope, I want. I was gonna say maybe I put it in the .o file, but it wouldn't build fine then. That would stink if you couldn't both emit dependencies and compile at the same time. Anyway, so that's what I'm trying to get done, and that'll be very nice, especially on the US side, because we have about 2,000 files now that we have to build, and that takes a while if you screw things up. Now here's the issue, and another thing that you have to be diligent about. I've had this philosophy for a long time. Let's look at stage. So we have stage overlays, for example. What does stage overlay include? It includes game.h. What does game.h include? Absolutely everything. One of my philosophies when working on projects is that dependencies are very easy to add and very difficult to remove. And that's what happens here. So, for example, stage includes sound effects. So every primary header for a stage, so we'll look at top, for example, top.h. What does it include? It includes stage. That includes sound effects. Every file basically in the top overlay includes top.h, which includes stage, which includes sound effects. So now if I add or remove a sound effect, regardless of whether that file has any reference to a sound effect, it's going to have to rebuild that. And we actually have, I think, hard-coded logic right now in that Ninja script to specifically look for these files. And what's nice is we can remove these, and we don't have to depend specifically on those files anymore, because we now have a way to pick them up automatically. So that's pretty sweet. I'm going to undo that because I haven't tested that yet, but that'll be nice. There's one other wrinkle in all of this, and that is the splat configs. Splat configs will also have a hard-coded list of dependencies, and I don't see those here. They'll be called symbols. Yeah, here we go. So these will be a part of the dependency list, and that's unfortunate as well, because I want to do some work with symbols so that we can get rid of the version symbols file and rely on just propagating symbols from lower overlays to higher overlays. Not terribly important, but we'll get into that in a bit. So next, what did I want to do? I wanted to look at the repo, and I haven't looked at this list lately. Not ideal for me. Oh, we have four pull requests. Two are mine. One is good, and I did this yesterday as I was going through top, which is Castle Keep, and RTOP reverse keep, I noticed that their room background functions were similar but different. And this code is copied into every stage overlay, which is like, that's the sad panda when that happens. So I wanted to see what the differences were. And so there were really 3 different aspects to this. One is most of the original code, we can look at it here, I believe incorrectly assigns the facing left field to the unknown 5A field. And I do want to look at that. I wanted to see what type that was. Yeah. So facing left is a unsigned 16. I want to make sure that unknown 5A is not anywhere close to that, because sometimes we see things like this where the compiler's optimizing a write to 2 fields when those fields are adjacent and a smaller size than maybe a load and store that it can do. So say writing 2 16-bit fields as one 32-bit field if they're adjacent. That's not what's happening in this case, though. This just looks like a bug. It's possible that unknown 5A had a similar name and it got mistaken and then copied everywhere. I don't know if that's actually the case. Maybe there's another purpose for it. I haven't looked too deeply into it. But other places that's fixed, and it correctly assigns facing left to facing left, and unknown 5A to unknown 5A to unknown 5A. So you can set a macro facing left fix, and you'll get that behavior. If you don't set that, if you're the PSP, you load facing left as a unsigned value and assign it to 5A as an unsigned value. That's because unknown. Why do you have to do that? I don't know. They're both unsigned, so why that instruction doesn't get generated, I don't know. I would think that it would. I'm not MetroWorks. Otherwise, if you're GCC, you need the signed version of that instruction, because GCC does not care at all. If it's doing a 16-bit load and then a 16-bit store, it knows that it didn't touch those bits in any meaningful way. So it's going to just write them the way that it read them. Everything else is the same, but then some of these also need this additional scale assignment. And so there's another macro for that as well. And most of the time, stages can just include that file and it just works. Sometimes they need the facing left fix. Sometimes they need the scale change. But then we can get rid of a ton of duplicated code. There are 2 stages that don't do this. So those don't get fixed. All right, so let's look at some of the issues here and see what we might want to do. Investigate char signed on MetroWorks compiler. So when what a char is, depending on your platform, may or may not be the same thing. I believe, I want to say the CSpec defines it as an unsigned value, but it may just be called a char and never specified. Let me see if I can verify that quickly. Yeah, I don't think the CSpec specifies whether char is signed or unsigned, and so MetroWorks allows you to choose that yourself based on what you want. And why does SozuD care? Because it looks like there may be something else going on there. I don't know enough background, so I'm not going to sit and think about that. Unable to build non-matching disk image. Don't care about that. Update the add new overlay instructions for the new build system. That actually is a pretty good one. And we can go through that, and we just added a new overlay, BO6. But we can go through the process and update the wiki, or not. Integrate assets and codebase using Inkbin. Don't know what that is. It looks like... Oh, yeah, that's actually kind of nice. So when we generate assets, include them as binary. Soten string we use so that we can write UTF-8 C files, but then convert them appropriately to... there's a couple things going on. The character encoding for strings in Symphony of the Night is not ASCII. It's not Shift-JIS, which is what Japan uses. It is... everything is shifted down basically to... so A is usually what... is it 40? Let's go to ASCII table. Let's go to ASCIItable.com. It's been a resource for me for decades. So an A... Yeah. So at is 40. A is 41. So imagine shifting all of these, basically 64 code points to the left. And then that's your character encoding. And so Soten diff, or Soten string, is a tool that was written so that you could write normal C strings. You wrap them in a fake macro called _s, and then Soten string finds them and converts them to the correct characters, which is sometimes a pain. We've run into this color lookup table thing on Doppelganger. Let's see. Some function, comments in some function. That's an interesting comment, and if we could reproduce that case easily. So it's saying that we have, there's comments in here indicating that the function is related to Alucard being turned to stone, but really it's related to Alucard getting stuck in some state. And there's voice lines and stuff associated with it. Clean up and unified build pipeline and folder structure. Yeah, I would like that a lot. Again, not necessarily something to do during a stream, and then add some overlays for HD. These aren't actually things that I necessarily want to work on the stream either. Let's look quickly into the add new overlay instructions and see what we can do. So there is a couple things that are an issue. This is correct. This is how you add a new overlay. You specify your version, run make config, and then what the overlay name is. And the tool knows if you specify a stage, it'll find the right directory in the stage depending on your version. If you're specifying a boss, it'll do the right thing, weapon, etc. We don't have to do this in the makefile anymore. That part is done, or not an issue. So we're gonna edit this, and we can go through and make sure that we can follow these instructions as we do them. I like wikis when you can edit just the subsection, but that's not what's happening here. All right, so we don't have to edit the makefile anymore. We don't have to edit the build version of the makefile, and we don't have to edit the pony section of the makefile. We do. We don't have to add the binary to the build step or update the build step. what we do have to add is add, and let's go over and look. Now, this is kind of a silly thing that we still have to do. We have to add the binary to force symbols. This is something that I actually would like to get rid of as well. And there's a way that I'd like to go about doing that, and maybe I'll talk about it in a future stream. So we're going to add overlay to force symbols. All right. And then there's one more. Oh, there's disprepare. Actually, I think I've been bad about doing this. I don't think top or rtop are here. So I will have to fix that as well. Oops. Okay. And then there's one, I thought there's one more. Isn't there a, yeah. I thought there was format symbols. And it looks like those are all dynamic now. Okay, so those are dynamic. We'll check BO4, yeah. Unfortunately, I did not. I have BO4 here, but not RBO5. We'll add that and act like it never was missing. So this lists the files that when we're building a new version of the disk, this lists the files that can be found. And rtop and rtop are supposed to be here as well, so we'll add those in as well. And these are kind of things that we know a lot of this information. We can get it from the splat config, but we're not doing that. And eventually we'll have rtop in this as well. So I'll add rtop as well and submit that separately from the rtop here. Maybe not. Maybe I'll put rtop in there first and do the right thing there. All right. So force symbols and disk repair. The phony target does not need to be updated anymore. The phony target, we used to have basically specific targets for each of those things. That doesn't exist anymore, so we don't need to update that. If you're adding a PlayStation overlay, we don't need to add that anymore. All of this goes away. We do need to add it to dupes, and we need to add it to progress. Is progress here? Yeah, progress is here. We don't have to update the README. The README now has all of the overlays. So force symbols in disk prepare, that was already there. The check version is there. I think that's it. You do have to add, do a git add on the new file that's created. Let's do that after this. So Splat by default will generate, well, not by default. The Splat config that we create will create source, st or boss, what the overlay name was, and then for US it's us.c, something like that. So you have to add that to your commit. Create a we need an overlay header file for that overlay, and I'll provide a template for it as well. I think this is how, or does it do 3 ticks? We'll see. We'll see if this this works. So we're gonna grab a the template for why didn't you copy? Okay, we're gonna paste that. Hopefully people understand that overlay means whatever overlay they're including. Let's see if that generated what I hope it generated. No, it didn't. That didn't work at all. That's okay. That's why we don't publish right away and preview, check our work. So we'll do this. That looks better. So format symbols we don't have to do anymore. I need to fix that as well. So format symbols is based on the Splat config, so we don't have to worry about that. For symbols, we still have to worry about disk prepare. As I said, we do have to worry about that too, and we have to add it to dupes. And then progress. I think that's it. we actually want to include stage.h like this. Hey, Peppa Giga Chad. Sorry, when I say it fast and miss it. Things are going well. Actually hurt my back yesterday, so things aren't going perfect, but it could be much worse. I have chronic is the wrong word. I have frequent back pain from an old, basically over 20 years ago, hurting my back once, and now every once in a while I'll just do something to trigger it, and I did that yesterday. No, yeah, and it wasn't anything like bone breaking. It was just stupid, trying to lift more than I should have, and then things happen, and then I can't move for a week or so, and then I'll be better, and then it'll be fine. All right, that's not perfect, but it's better than what was there. This is something we probably should do in make config, and maybe I'll add that. So I'm going to write a comment. So basically, we have a lot less that we have to do. We used to have to put new overlay information in a lot of different places. Now we don't have to do that anymore. Uh-oh, something happened. I just had something disappear on me. We'll see what that might have been. I don't know what it was. Oh, it was Finder. Weird. Finder crashed. All right, save the page. And then I'm going to update the comment on that issue. So make config, I think, should generate overlay.h. I think that'd be good. Let's stick with that, and we'll see if somebody wants to close it. No, we just hadn't updated it. So a couple of months ago, Dynamo changed. Basically, we were using make for building everything. He moved builds over to Ninja, and not the move to Ninja necessarily, but along with that came scanning for splat config to find the necessary overlays, and just a whole bunch of other nice updates. And so a lot of the duplication that we had in the build system wasn't necessary anymore. Yeah, boring docs work. It was an issue. I wanted to see what issues we had, and if there's anything that is interesting. So far, it's been tooling on the stream, which is, depending on your perspective, it could be exciting, it could be boring. Any of these things are force multipliers, where if we automate, basically we enable other people to go faster, and that's pretty important. Especially for people who have familiarity with some of the inner workings of the build process and other things like that. I won't go. I've added several overlays on the stream before, so I won't go over adding new overlays. But if decompiling is something that you're interested in, there's, I think, 2 great ways to get started on this project if you want to. If you go to the same decompilation wiki that I was just on, you get the project set up. Finding a function that hasn't been decompiled yet is pretty useful. The duplicates report is unfortunately having some issues with symbols, which is a bummer, and I should spend some time and fix that. But the duplicates basically going to this file, looking for a false somewhere in this file, entity skeleton pieces. That should be a very easy kind of first change that somebody can do. Basically, it tells you everywhere that this function is included. It'd be kind of nice, maybe, if it told you the C file. I could look into adding that as well. Dupes is written in Go or Rust? Rust. Go. Rust? Yes, main.rs. It was actually the first Rust code that I've ever edited. I'm not the author of Dupes, I just have made changes there. Dupes is actually one of the coolest things that there's so many cool things on the Zone Decomp project that I had never seen before in a project. And Dupes is one of those things, doing fuzzy matching of code to find duplicates. So pretty cool. Anyway, that's a good way to get started on the project if you're interested. And of course, soten.z.dev is how you get to all that stuff. But now let's actually decompile something. I always want to say there is a oh, what did I not write? Does that all look fine? Yeah, I added verbose to a lot of the Ninja commands so I could see what it was doing. Oh, that looks fine. We're not going to add that to it yet. All right, let's find, what branch am I on? I'm not on Bobo 6. So I need to, we're going to git stash because I don't know what's out there. I'm going to check out BO6. I'm going to pull and rebase. I don't think anything's been merged, but maybe I'm wrong. Oh, there was something. Pop that stash. And let's build. See where we are. Yesterday we were working on a function that didn't get finished, and I didn't come back and finish it. What I think I'm going to do is, instead of finishing a function that was... Oh no, we did finish it. That's right. The function was finished in decomp.me, but it had an odd alignment thing going on where have I gotten over my initial gripes with Ninja? I understand it now. Dig Down Deep was asking if I got over my gripes. Having... I always prefer declarative configuration over like dynamic programming configuration, and so I'm still in that camp. How do I feel? I love what Ninja enables us to do, and adding so I added the dependencies thing. That would have been a nightmare to add in Make, and is very simple, but that's because Make is stupid and doesn't do anything for you. You have to use AutoMake or something like that on top of it. And so Make does enough. Ninja has all the things built in. I don't know. I don't know how I feel about it. I'm just happy that I can build fast and build faster. So we are doing that. We're building fast. So we had this this function yesterday. I was struggling with why does the alignment not work out. I never did come to a conclusion of why the alignment didn't work out, and I didn't want to look at it last night, so I didn't. But what I want to do instead is look at who calls this function, and then maybe we can learn more about why the alignment is strange into the entity table from that. We're going to look at boss B06 and just do a grep for that. Who calls this function? And it looks like it's this one, BA168. And what can we tell about this function? Oh, it's 6K. It's not like the worst ever. It has a big jump table. So let's do that one next and see if potentially we can see what fields are being manipulated or read in that function. Yes, I didn't figure it out. I realized yesterday that when I was doing the math for that function, I was looking at primarily starting with this first entity, the -1. It probably actually is based on these second ones because there's possibly two reads here. Again, going to the PSP version or anything else like that probably would make this a piece of cake. I'm going to go to the caller of that function, and we'll see if that gives us enough information to fix it. So this is another small one. Let's hope that it doesn't include something crazy. So this is interesting. We have up to a case 26. Is this order right for the switch? We'll have to find out. Is this what was our other function yesterday? E8. What are we passing to E8? Something related to a collider, probably. And whatever's on stack pointer 16. Also part of the collider. I'm guessing that this is a collider. I don't know for sure. So this is actually going to be a doozy in its own right, but we'll try to get through it, power through. So I'm going to do a couple things that I like to do. I think that these are both signed 16s from our work yesterday. I'm going to throw that into the context. So now we have that information. What else? I think that the first arg here is going to be a collider pointer. And then we're just going to assume that those others are ints. GCC, it won't really matter. Let's do signed 16s. It will matter on the PSP. And if we have some entropy here, maybe we can figure that out. We don't know what the third arg is here. So I'm okay not guessing. And var A0 doesn't look like, var A0 is some kind of pointer. Some kind of pointer from this data. Probably an array of something. So let's look at that. Sometimes Splat gives us enough information to figure that out with its disassembly. Okay, so I think there's a couple hints here. I think that they're 16-bit values. I think that this is a what? So the FFFF here is a common terminator for not the Arnold kind of terminator, but for something. Unfortunately, FFFF is also -1. -1 is going to be much harder to search for. Let's look for that. Not seeing anything right now in the includes that make that obvious. What about U short max? U 16 max? Any max anywhere? Anywhere? No. Okay. So I'm gonna go with unsigned 16s here. That's what they look like. It could be. It's possible that they're like points, 0.32 with two 16-bit XY. But I don't think so. Yeah, I think it may be pairs. The FFFF looks like a Terminator to me, though. Which means that they'd be being read. And I would have to find a counterexample, but it looks like they're all 16-bit pairs. So you're probably right. They could be 0.16s, and they could be shoving the FFFF into the X field of a 0.16. But let's say that they're pairs of, because we don't know any better, pairs of 16-bit values. And so we'll say this is a unsigned 16 array of 2s. And what else do we know? Let's look at 1CO. This is the same thing. So we'll grab that one too. I hate the multi-dimensional array syntax for C. It's pretty terrible. I would want to write this as a set of 2s, of which we have an array. But even more than that, I'd probably want to say unsigned 16 2 by n, like Java. I don't get my way. So what are you going to do? So I think let's decompile again and see if M2C can figure out any more, or if we can get a slightly better place. Unfortunately not. Let's try to get through it. So I get rid of all the function declarations, and then we rely on the implicit function declarations. That may or may not be right, but it'll get us closer to compiling, and we can always go back and add those later. SP10, we're going to call it's going to be a collider type. I'm guessing, just a guess. Okay. Roaming saying bracket comma 2 for an arbitrarily sized array of pairs. So for the unsigned 16, this could be a pointer, but its declaration here is fine. I don't have any issue with that. So we need to deal with SP16 and SP1B. Let's go over and look at, I'm guessing this is a collider, but it might not be. Do we have something at B? No, we don't. And so that sucks. That is one hit against this being a collider. This could be something that we've never seen before. It could be something specific, but it's probably something related to Richter. So if we don't find anything obvious here, then we'll have to look over there as well. What else? Sometimes you have to unwind these a bit as well. Get some information from an earlier function. The other thing that I'm not really thinking about is, we have some fun things potentially here. In Doppelganger, we had a virtual control pad, so we're going to be able to play as Richter, I think. we had a virtual control pad, and we could basically put whatever inputs we wanted, including the controls that were currently on controller 2, for example, and input all the controls for Doppelganger. I think we're going to be able to do that with Richter as well, and I think that's what this is here. We're checking if a particular button is pressed and then leaving. We got to get much further in before we confirm that. Thank you. So this is my guess is that this flag is a button, and that this is going to end up being a struct that, or just a 32-bit value that emulates the G-pad. We'll get into that in a bit. So what we need is our stack pointer is going to be at offset 10. We need something with a field at 0, a field at 6, and a field at B. So I'm going to go back over here and look for things that have a field at B. Subweapon actually is not the worst. I can see that being related to Richter. And so maybe this is setting some subweapon state. We could try that. Let's look at the headers in Richter, see if there's anything there. I don't see anything. And include anything else. So we have this. Game settings, doubt it's that. So let's go with subweapon def. So I was wrong about collider. We'll see if that's correct. It might not be. So we'll change this. Grab a new decomp and start over. That gives us our field names. And so if nothing else, we have a starting point, and that's really the best we can do for now. Let's get this compiling, and then we'll figure out maybe what is right and what is wrong. Alrighty, so I'm gonna reorder. Let's get rid of this block 8 first. It looks like these are always going to be the same. var a0 is not actually going to be a variable. This is just going to be the argument. A0 register is used for arguments. So this is just an optimization from GCC. That does. What were we at? I don't know. I think that's a little closer. Get rid of that block 8 and get rid of that assignment. So I think that gets rid of var a0. Thank you for your service. Var v0 basically is our return value. If this function failed, we're going to return 2. Otherwise, we're going to return 0. And we can get rid of that one as well. V0 is the return register. And that gets us almost all the way there. 40. You missed all the good stuff. Let's go back. Do it all again. Where was I? All right, so this is what we started with M2C. We're going to do it all again. Let's... I'll start over from the beginning. Block 8. Var A0, this is our argument register. And so we don't actually have a variable for that. It's just where the argument is stored. So we're going to get rid of all of those. And then get rid of A0. And that gets us close just by itself. Var v0, I'm going to... so what I originally tried was making this return 0. Because if we're inside the return, that's what's going to happen. If we don't go inside the return, it's going to turn into a 2. That didn't work like I wanted. It actually gets us almost all the way there and successful. That does not mean that what we have here is actually a sub-weapon diff. Still not certain that that's what that is. It does reserve the correct amount of space on the stack, but it looks like that's 16-byte aligned, and so that could be a coincidence. The types also aren't critical on the PlayStation, so this chain limit being assigned 16 might not be right. So I'm not gonna argue for this being the correct struct type. It just works for now. So the var v0 though, so we're using that v0 as the return register. We don't assign things directly to it. Things get put there. So when we're returning, we put a 0 in var v0. But that's not working. It's putting it in the wrong place. So I'm going to try one thing. I'm going to make this an else. There's two ways that I'm going to try to do this, and hopefully one of them works. This one didn't. So what if we... this is what I like to do anyway. What if we negate this? Or no, we'll... the less than equal maybe is the giveaway. So we're going to change that, or greater than equal. We're going to change that to a less than, so we've inverted it, return 2, and then get rid of everything down here. And we've reduced one level of nesting, and that does it. So we're still not out of the woods. This is a strange thing going on here. So we're assigning the value 4 before the switch, and we're also assigning it after the switch. Both appear necessary. Make a comment there. The instructions are generated for both of them. It seems like whatever context the GCC optimizer has. Well, there's a couple things. We don't know that any of these functions didn't manipulate that. That's definitely possible. Dizika saying chain limit makes sense because yesterday we were looking at the second argument max count. Yes, that's possible. And so here we are doing a Boolean. And so let's keep going in this. First, let's see if it compiles, and then we'll keep going and see if we can figure out these other ones as well. I'm not gonna take the function declarations because usually we don't need them. We'll see. We'll see. So we need to find where this function is. So again, this is Richter. Once we have a relatively solid starting point for Richter, we should actually be able to go back and look through the Richter code and find a lot of analogous functions. And that, hopefully this is maybe the starting point for that. If this actually is the subweapon struct, we should be able to find a function that looks like this. It didn't work. So we want if boss v06. So our issue is somewhere along the way. Oh, am I not including? Yeah, I am including stage. I have all the right data types. Okay, so if I get rid of the function signatures, sometimes they matter. Do we generate different instructions? We do. So in this case, we do need at least one of the function signatures. Which one? We need this OE8 function signature, which is the function we were working on yesterday. So the way I realized that we need that function signature, I got rid of both of these, and we no longer match. And we have 300 differences. We have one completely missing instruction and one incorrect instruction. So sometimes it matters. Most of the time it doesn't. And most of the time it looks like they didn't provide them. And we can tell that from the PSP because MetroWorks is much more sensitive to it than the PlayStation is. GCC is. So let's look for this now. We'll look for subweapon def in RIC. Not a lot of functions that have a local version of that. Let's start with this one. Very odd abbreviation of subweapon def. Can't spell it. Gotta copy it. What do we have here? Not quite the same. But my guess is that 1000 macro here. Oh my goodness, we have, this is so much, this is probably the wrong overlay for me to do because I have PTSD from Doppelganger. But we're going to have a lot of the same structures. And this is actually super helpful because we're going to get, we're going to have a G player entity. That G player is going to look like player. There's probably a lot of places where instead of player, we're going to have Rick, just like we had Dop for Doppelganger. This is going to be, yeah, I think very similar. And that's good. We know how to do it. So I'm going to look at game. Add up is 1000. So that looks like maybe what we're looking at. Let's look. I'm going to put these side by side. Not tab new. Split. Source brick. PL set step. Yes, roaming. This might be a spoiler. Sorry. Close your ears if you don't want to hear spoilers about the game. Richter is an enemy in the game. It is true. Sad but true. Sick sad world. We have some interesting things here. These are false instead of. No, this is a little different. Check subweapon chain limit. Oh my goodness, this is sick. This makes me sick. All of this makes me sick. You played until the flip, then you played Richter. You have to fight Richter to get the flip. You have to. Well, no, you actually explicitly do not have to fight Richter. If you fight Richter, you won't get to the flip. But you have to go through that path. And so maybe if you're going through a walkthrough, it might have had you get the holy glasses without realizing why you needed the holy glasses. But with the holy glasses, you see that Shaft is controlling Richter. Again, spoiler alert. Sorry if you've not played through Symphony the night before. Huge spoiler. Yes, Richter is being controlled. And yes. Yeah, so if you end up fighting Richter and defeating him, you get the bad ending, because it was not Richter who was the Lord of the Castle. After all, it was Shaft manipulating him, and the Holy Glasses allow you to see through that facade, the veneer that Shaft has put over him. All right, so long story short, I don't like the case 26 being at the top. Let's look through Richter. Oh, and we have all the steps. Oh, this is, oh no, this is so terrible. So we got to do a bunch of things before we can actually integrate this. I say it's terrible, but it's not. It's actually very nice. Gross. So we have to do a few things. We have to create a symbol for Richter. Everywhere, we're going to be copying so many of these functions. Everywhere it says player, it's going to be Rick. Everywhere it says G player, it's going to be G Richter. Everything else is going to match almost identically. We have a ton of names for all of our symbols. But we have to decide, because with Doppelganger, it was nice, because Doppelganger is called Doppelganger and Alucard is called Alucard. And so we had the Dopp namespace for Doppelganger. What do you call enemy Rick? Yeah, I mean, it is. It's great. I couldn't have asked for more. Had I not been the one to work on Doppelganger, I wouldn't see these patterns in Richter. So, yay. We did it. Boss Rick. Yeah, it's just long. But B Rick? Can I call him B Rick? Rick? So what we're going to do now is a bunch of symbol mapping, and you might find that exciting, you might not find that exciting, but that's the next thing to do, really. So we need to find where there's going to be a likely, and this is a pain, and I might do something different this time because it was such a pain for Doppelganger. There is a player state struct, and somebody at the beginning of time being 2022, 23, came through and decided there's only going to ever be one player state. Why would there ever be more than one player state? And so they put the VRAM addresses for the entire player state in the struct. Usually we put offsets in the struct because those could be anywhere in memory, but in this case there's only one player state. It's a singleton. It's only going to exist one place in memory. No, it exists for Doppelganger 10. It exists for Doppelganger 40, and now it almost spilled. Now it exists for Richter as well. And so with Doppelganger, what I had to do is look at the start of the Doppelganger player state, subtract whatever field that I was looking at, that address, get the offset, then add it to this start of the G player state. It was just a pain, but we're going to do something slightly different. I might update this with offsets because that will make my life less miserable. It's a big object as well, so we will get a lot of value from mapping this. So we're going to do symbols.us bobo6, and we're going to call this grick. And where does grick start? To find that, we have to find a field that we know, pad pressed. We have to look at what address we're currently reading, which is this 801D5EO. I have to put that into a calculator, which I have open somewhere. And then this is terrible. So actually, before we get to do that, let's find pad pressed. And this time I am gonna calculate the offsets first. Fortunately, we have no macro for pad pressed, or no symbol. Why? Why did all those symbols go away? Who did that? Who? Ugh. Defeated. Let's look at this. I thought we used to have... No, that's player. Okay. Okay. Why need offsets? Oh, but I can just calculate that. That's right. Okay, so I'm going to take the 72EE8, subtract BDO, which is where it starts. That gives me 318 in hex. So pad pressed is at 318. Where do I want that? This is how SPIM does it. It puts the offset first and then the VRAM second. So I'm going to do the same thing. So pad pressed is 318 afterwards. And so now we have our starting point, which is pad pressed here at EO. I'm going to take that, subtract 318. That gives us 12C8. So we'll go back over here. And I can add a comment to the symbol file that says size, and it says the size is 3DO. Not the game system. The hex value. It's pretty big, player state. So now when I do a export or a split, all of those, every symbol that's within that range for Richter will be GRIC plus some offset, which will make it easier to find in the future. That's nice. I like adding other things too, but I'm not going to do them because they actually end up screwing that up. Something like this, pad pressed. We know exactly where pad pressed is now. In VRAM, it's at this address, but then the size offset doesn't. You can't use both of these things at the same time, which is a bummer. I'm going to keep it here for now, and until I format, this will stay here. So that is that. Let's look at that address and make sure that looks like a pad pressed. What we should see, or it's not pad pressed, looks like a player state. We should see 3 really big collider arrays at that address. That's going to be in ASM, US boss, B06, data. We haven't split data at all, so it's going to be in 0.data. Oh, it's in BSS. Is it? Yes. Do we have a really big array? Yeah. We do. And there we have our EO, which is a 32-bit value. Does that align with what pad pressed is? It sure does. And then another 32-bit and another 32-bit and another 32-bit. So do we have 4 32-bit values in a row? Yes. And then an unused one. And then another 32-bit value? Yeah. And then an array of 16-bit values. And those are individually accessed and the offsets are computed. So pretty likely that this is all part of the same struct. So that's good. Happy. Now we can do other things too. We can start naming things. So let's open up that same file. I'm going to call it brick. brick. Let's do this. Let's do a overlay export VO6 Rick. Don't like it, but it follows the pattern. Do subweapon. Let's actually look for this real quick. Subweapon def. I wanted to see if this was item crash or not. It's not, and that's what the check for pad up is, to determine whether this is an item crash. So now we know everything there is to know about Richter boss. Oh, come on. Yeah, copy that. Sometimes Vim flows from my fingers like nobody's business. And other times I feel like it does not. And I have to think. So we have this function name. We have to update our function that we just imported. And we have a nice macro for doing that, OBL export. And we're going to call that Rick to subweapon. I had that in my copy buffer already. And we should be able to make, and some magic is going to happen. Why? Why is it rebuilding everything? Oh, because I changed. This is what it all comes full circle. I changed game.h. What depends on game.h? Everything depends on game.h. Does everything really depend on game.h? No. But because we specify it for everything, we basically have to force rebuild the world. But that worked fine. And now we know what this function is, and we know what the other function is too. And we can figure out now what was going on with that offset. And what was that offset? And that's basically why we did all this to begin with. So we're looking for the check subweapon. We don't have values, they're just booleans. Let's find where that is. Oops. No, stop. Let's find where that's declared. Does it kind of, I'll show you what so does it asked on YouTube, since I included the size comment, will it give me symbols based on GRIC? Unfortunately, SPIM doesn't know the struct, the shape of the struct, and what all the field offsets are. That would be great if it could do that. That'd be awesome. What it will do instead is when it generates the disassembly, it will put GRIC plus some offset. And that will make it relatively easy to find what the field is. And we'll see what comes with that. We'll go look at what those assembly files look like now. Oh, it might be in DRA and not in RIC. That happened. No. RIC check subweapon. I included the bracket because I was hoping. I'm going to assume it's S32 return. Weird. I figured the arguments were all on the same line, but it turns out that they're not. Oh, crazy. Okay. So quite a bit different than I expected. These aren't counts. They are used as booleans. We can use bool. Bool is defined as an integer, assigned integer specifically in C. So we can use this this argument. I like using bool. Not every compiler though is compliant with that. Oh, this isn't the function we were working on. We were working on the one that takes 2 arguments. Get back there. So not the check subweapon. What is subweapon ID? Hold on. Of course, the D needs to be capitalized when the P and the N aren't. Let's go down here. Here it's called subweapon ID. We're not passing that, though, to another function. So it is possible that the value here is being assigned to the A0 register, and it's not actually being passed to this E8, AOE8 function. Oh, or it is, duh, and it's called, sorry. I'm slow sometimes. I'm really slow. Pardon my ignorance. There we go. That's what it is. So it wasn't what I originally called it, POSX and max count. It is subweapon ID. And what's nice is, though, that this will tell us some interesting things about the subweapon, potentially. A lot of this looks just like we thought it was. It's a little different. So let's see if we can fit this in. So entity was assigned, and basically there's certain ranges that are kind of hard coded in. So this is entity ID 96. Anything after entity 96 up to 32 of these, it looks like, is going to be checked. We do have position count is going to be called nfound. Looks like this check was the opposite. And we will see if that works. Max count. We're now calling that limit. Subweapon ID. So here for entity, we are checking the current entity, and that is the entity ID. And it's just a not. That probably came from the PSP. The PSP can tell us if it's a not or a equals 0. And then this is part of the entity extension subweapon. And we don't have position X. We have the subweapon ID. All right, and so we're no longer matching, but we have a lot more information. Room index count, we're going to rename that to n empty to match the other one. So let's move the assignment down like it was before. I'm have the Richter version off to the side. We're iterating through quite a bit less in the Richter version. I'm going to do the same thing over here. So this looks a lot better. We do have the plus I here. Oh, that was the issue. I see the issue. We need an entity plus plus. That's what was missing. There we go, and now it works. Now everything is perfect. Perfect in every way. Thank you, Richter. So we'll go back to our AE. Oh, and that's why we have the function declaration, because it comes before, and so we don't need We don't need a separate one. We just need it as part of the definition of the function. Sweet. It's all coming together. I love it when a plan comes together. I'm going to name this the original automatic name just to get it compiling. And it works. Oh. So if you were watching yesterday, we have success today. That's why you keep working on things, even after you don't want to, because it's just a matter of time. So I'm going to do OVL export for this as well. OVL export, it's a lot of characters to basically prepend this function with BO6, but it makes it portable. So we could actually move this into Richter, name the same thing, and it would work there as well. Could we just call it brick check subweapon chain limit because there's only going to be one of these? Probably. I'll make that decision later, I guess, if I'm going to do that or not. So we need to put that in the symbol table because... do we? No. There's only one reference to this function, and that reference is already decompiled, so we don't even need a symbol for it. We just need to make sure that the reference is updated to point to the right thing. So we need to find that AOE8 function. Change the call to our OVL exported version. And that all works as well. Perfect. Oh, there was one additional thing I want to do, which was move case 26 to the bottom. So our switch here is really small. Actually, there's a couple more things that we're going to do before we end. Our case is relatively small, but we had a jump table associated with it, and that's... Oh, it has to be in that order. Okay. That's because it goes up so high, and so basically at some cutoff, GCC says I'm going to use an external table instead of generating conditions, Boolean conditions for each of these to do the check to see whether these match. There is more likely that we could do here. Since we're in do subweapon, we know that this is now GRIC step. But what is GRIC? We don't have that defined yet or declared. So we're going to add a BO6. This is going to be used a lot of places. Normally, I don't like putting things in the stage header unless they're used by most of the things in the stage. In this case, it is. So we're going to have a G player, an external G player called GRIC. I'm going to confirm before I compile this that that is the same as BO4. We're going to have a lot of the same things. Oh, I didn't. Oh, it's in... Because Doppelganger was used for two different bosses. It's in doppelganger.h. Oh, not gplayer, of course, player state. And we do have that there. So we're going to have a couple other things too. We need this doppelganger step enum. We're going to see that these steps, we call them OVL export Rick steps. I don't know about that. These are going to be the same as Richter's steps. They may be offset by one. That's how Doppelganger was. Everything was +1. What they were for Alucard, I think. So let's look at Rick.h, and we should have Rick steps somewhere in here. We're going to have to go through whatever attacks Richter can do as an enemy. They're all going to be there. Probably going to have the same blueprints, or a subset of them. We're going to need all that too. Subweapons. Richter does a lot, but the steps aren't in there. Where are the steps? We need to find... Which one? Oh, they're PL. PLS run. They just weren't named what I expected them to be. Okay, so PLS, I guess, player steps, Rick steps, okay. Name the same thing. So these start at 0. I think ours are going to start at 1. Stand, walk, crouch, fall, jump, and run. That makes stand equal 1. So I do think this is going to be basically the same as Doppelganger. And unfortunately, that means that there's going to be small variations in all of these that we can't just rely on the Doppelganger, the Richter implementations, but we can, everything's going to rhyme with Richter, just not be exactly the same. So let's check that for run. That does look like offset 26, so that looks good as well. And let's make sure that that is actually good. No. All right, we screwed something up. I screwed something up. Let's undo those. It wasn't the step, or GRIC isn't pointing to the right thing. Okay, I'll fix that later. We can figure out what offset that was. Oh, what did I do? Yeah, GRIC step. Oh, it's not from GRIC. It's from player. Oh, this is easy too, and we'll make a macro for this. So we're gonna have a Rick macro, and the Rick macro is what? It is going to be offset. I can't remember. How can I be expected to know these things? The stage start entity. So we'll have our Rick macro. Thank you for pointing that out, Dizik. Appreciate it. Always helpful when people are here to check my work. Because otherwise I bang my head on the wall for a while and then eventually get it. So that worked. So we have an entity. This is looking at the entity, not the player state. And the player state is an entity in the entity table, and Rick happens to be the first entity in the space reserved for things in the overlay, just like Doppelganger. All this is going to be, and I mean, this is going to be super frustrating, but actually really good. It's going to be Rick, and it's going to work. And he stands when whatever is happening here, when his current step is run, and whatever case was happening he wants to use as weapon, he's going to change to stand. This actually is pretty nice as, pretty nice as well for seeing what the behavior of these enemies is and learning about that, because we know a lot of this from the player perspective already, so we can figure this out. So basically we cracked the nut that is Richter. Everything will go pretty quickly for a while until we get to things that are hard. The logic for how to choose each of these things, because we have like 200 functions, so there's going to be a state machine that basically says, what is my current step? What is the player doing? Blah, blah, blah. This is what I do next. It's the logic is pretty straightforward and reasonably simple. but it's long, and we'll get to it eventually. The hard part is just getting these initial symbols and their types, and what we'll see is basically these will all look a lot like Richter. You can just keep going through and updating symbols. Ah, cut it out! Stop disproving me, thing. This should be what I changed it to G Richter, right? Is PLT coming from where? Yeah, okay. So it's in here. We need Rick timers. I'll probably share this, move it out into a shared header. I can't include this specifically. This should build fine. Yeah, now that works. Now that we have the macro in place, and the macros are identical. And we'll just keep going. We'll keep going from there. We'll now that I know that this is what it is, I'll go through and clean up what I can. And the sub-steps are hard because basically for every step there could be n sub-steps, so we don't have macros for, or enums for those yet. But that is that. We know the names of these functions or what they should be, so we'll add symbols for those. We have the timer up there too. And then, yeah, we'll just keep going. So this is awesome. We cracked it, and now we keep going. We have all these globals that we don't need anymore because they're all part of either entities. Shut up, compiler. 170 I need still. That's up above. Which one of you didn't I change yet? Anyway, oh, of course, the GRIC up here. I love getting rid of global references. Perfect. All right, so that's great. That's all I'm going to do today. I appreciate everybody showing up. Thank you, Dizik, for all the help. Roaming as well. Happy that we had the breakthrough that we did. Go to soten.z.dev to learn more about the Symphony of the Night decompilation project and all the progress we've been making. I still don't have my top stuff in. I got sidetracked when I found that eRoom background was the same in everything and did all that work. And then decided that it was too much work to include in the top change and submitted it as a separate PR, but now my top, or sorry, our top reverse keep PR depends on that one. It'll get in eventually, and we'll get the progress there, and it will be a swoosh. But that's it. Have fun, decompile something, join us on Discord. Adios.